Okay, as we're talking about transfers of energy, we're going to do a little Bob Ross drawing here. I think I've referred to him as him before, pardon me. But if I haven't for some reason, and we haven't done one of these lessons, go ahead and Google Bob Ross, PBS. He used to be a kind of instructional step-by-step painter that had a little program on public television and had the world's most wonderful afro and just the most calming, quiet affect as you listened. It was also a great show to take a nap to. But anyway, we're going to do a little step-by-step drawing here. Feel free to pause this along the way to catch up if you need to. This is a concept that you should be familiar with at this point called the water cycle. But we are going to look at transfers of energy within the water cycle specifically. So we're still going to label all the parts. At the end, I'll try to zoom in a little bit, and you can pause it at the end and pick up on anything that maybe you missed along the way, or if you want to clean up your drawing or a little bit, something like that. So let's just go ahead and start. I like to do this real simply, and what I will do first is the most important part here. The engine that drives all of this, which is the sun. Hopefully you can see that okay. Move that up a little bit for you. There we go. Excuse me. And then what I'll do is we're going to draw a little hillside here. Okay. And we'll put our body of water. Okay. So what I think we'll do here first is we'll just draw all the components of the water cycle, and then we will look at the energy transfers that are going on within this. So as we look at, excuse me, as we look at the sun beating down on Earth, it's obviously hitting water, which is about 70% of our planet, but it's hitting land as well. And so as the water turns from liquid to gas, we refer to that as evaporation. Okay. This water vapor rises up in our atmosphere. It cools and condenses onto dust particles. Okay. And then we call those big white fluffy things, which are just a big pile of water vapor and dust particles, we call these clouds. And that process is condensation. As those clouds move around, eventually the temperature drops that are either pushed upward into cooler areas of our atmosphere or up over mountains like we experience in Colorado, or for some reason that that water vapor continues to cool and that cloud can no longer hold on to that water vapor anymore. And then we get, I'm just going to put another cloud over here and some arrows down. Hopefully you're with me so far. We got precipitation. I'm going to add here a little, just for some scale perspective, a little house. Okay. We're going to put a few trees on here. You can do triangle trees. You can do broccoli trees. And as this water hits the ground, there's a bee. Okay, a little friend. As this water hits the ground, it can do one of two things. Okay, some of it will soak into the ground, and so we'll get some of that water that actually soaks into the ground. And that, as it soaks into the ground, this is called percolation. Okay? Percolation. The other bit of water that hits the ground is not going to soak into the ground, and it is going to flow to collect in streams, lakes, ponds, rivers, oceans, all those kinds of things, and we call that runoff. Okay. We also have, as the water percolates into the ground, plants use this water as part of the photosynthesis process, and they actually sweat. And what we call tree sweat, that's not what we call it scientifically, but this is called transpiration. So transpiration. A-T-I-O-N. Okay? That's why sometimes it feels more humid when you're in the forest. You'll notice that transpiration there. Okay? All right. So we also refer to this area here as collection. So when it collects, oops, hard to write sideways here. Collects again in large bodies of water, streams, anything like that, we call that collection. All right, so this is our basic water cycle. We've got 1, 2, 3, 4, 5, 6, and if you count the sun, 7 components of this. Okay. Now, here's what we want to do now: is we want to add the transfers of energy on Earth. So as we look at energy coming from the sun, okay, so we're going to add this. Energy that comes from the sun comes in visible waves called electromagnetic waves, and this is referred to as radiation. Okay, I'm going to get up for a second to write on this one. Okay. This type of energy does not need a medium to move through, and so it manages to travel through space to our planet, and that's our first transfer of energy. Okay, so solar energy moves toward Earth through the process, of radiation. Okay. As the sun's rays hit the surface of the Earth, okay, they hit the water, they hit the land, and we know some is reflected and some is absorbed, and the reflectivity of that surface is called, right, albedo. Okay, so darker surfaces reflect less, or they absorb more. Lighter surfaces reflect more or absorb less. So as the sun hits the surface of the Earth, it warms up the surface of the Earth unevenly. Right? So some places or substances and colors more than others, but it heats up the surface of the Earth. And so we go here, right, and here. This is all radiation. And I'm going to try to use 3 different colors here just to make this a little easier. Okay. So I'll use black here. So as the surface of the Earth, if you think about this, our next transfer of energy is along the surface of the Earth, the surface of the water, the surface of the land. These are areas that are touching the bottom of our atmosphere, and that is your key term here, is touching. The next transfer of energy is a transfer of energy that can only occur when 2 substances or objects are touching. Okay, so think about a light socket in your house, right? If you walk past the light socket, you don't get shocked, right? It would be only if something were put in the light socket. Do not do that. Okay, but something were put in the light socket, then you would get shocked. You can wave your hand in front of it. You can walk past it. You can accidentally lean against it. Okay, hopefully the button of your pants or something like that doesn't go in there, but still, it's deep enough inside the wall that should be fine. So this next process is that the radiation heats up the surface of the Earth, and the surface of the Earth transfers thermal energy to the bottom layer of the atmosphere through the process of conduction. So to conduct. All right. So now we have conduction. And again, must be touching. So conduction. So now our atmosphere is heating up. Again, only the bottom layer of our atmosphere is heating up because it's touching the surface of the Earth that's been warmed by the radiation from the sun. Now what happens to warm air, right? It rises, right? So you're going to have this warm air that rises up through the atmosphere. Okay, I'm going to use a new color here. So hot air rises, cold air descends, right? So hot air rises because it is less dense. Cold air then will sink and take its place. This is where we get wind. Okay, we'll talk about that a lot more in the next unit, and we'll actually come back to this as well as we talk about the interactions of weather and climate in the next unit. But as we move up, we have essentially a movement. So you have warm air rising, it moves up into the atmosphere where it's colder. Guess what happens to the air? Yes, it cools back down. And we start to get this cycle. This is our last transfer of energy, which is called convection. Some of you may have a convection oven at home. Basically all this is an oven with a fan in it. When you have an oven, it's going to have hot and cold spots. Convection ovens move that air around to make the temperature more even inside. It helps the food cook a little more evenly, sometimes a little faster. Okay? But those are our three main transfers of energy. Radiation from the sun warms the surface of the earth. Okay? It moves through our atmosphere, warms the surface of the earth. The surface of the earth that is touching the bottom of the atmosphere, right? Touching, transfers that energy to the bottom of the atmosphere. Okay, through the process of conduction, that air becomes warmer, rises up into our atmosphere where it then cools down again, and you get this cycle that is called convection. Okay? So that's basically it. I will zoom in a little bit here in case you need to pause this. Well, that's about as close as I'm going to get anyway. But if you want to pause it right there, you'll essentially get everything you need for the remainder, or pardon me, for this lesson. So if you need to look back at this or you need to perfect your drawing a little bit.